All right, just jump in here and ask any questions if you got them. All right, the chapters look like real numbers, rectangular coordinate system, introduction to relations and functions, equations, lines, reviewing basic concepts, interval notation. I'm trying to get rid of that. Yeah. Functions, run, change, equations, seeing how it gets into functions, just bear with me. I think it's 1.5. Linear functions are up at, starts in the inequalities, intersections, okay. Mostly chapter 1. Does it go into chapter 2 at all in the first unit? Yes or no?
Yes.
It does. 2 point what?
2.1, 2.2.
That's the nonlinear. 2.1. Basic ratio, vertical, horizontal shifts. There we go. All right. How many in chapter 1 do we go over?
Just 1.2.
Okay. All right. Done there. And now we're getting ready to start. Now we're still in review mode, so there's a little bit of stuff that we're going to be covering that you may or may not be familiar with. One thing that I do in my algebra and calculus classes is I do go over right quick. Some of you may not remember stuff as quickly as you want to. But what I tell students, if you need reviewing, go to YouTube. Type in Hubert McClure. Click on the blue shirt. Go to playlist. And you've got pretty much any class you want to review in. Let's say that you need to review over 102. Well, go down here. It's been a while since I taught 102. There's 102 right there. So you can go over any subject area in 102, graphing, interval notation, domain and range, anything you want to go over. All right, let's say that you took, you want to go over something in 101 or whatever the case may be. You can go over and look at any of these classes, and I would probably suggest the review that you're looking for is the 102, which is right here. Okay, it's been summer 2015, so it's been about a year and a half ago since I taught it, but it hadn't changed, it's still the same. So if you need a review on 102, there it is. Okay? I always give students that option because some people don't like to go over a review too much because it's a little bit embarrassing. So that's why I pretty much leave it up to you to do your own review. So we need to review over graphing. We need to review over functions. We need to go over domain and range. Those three things we're going to go over today. This is 1.2 material. And I think you have a homework section on it, so after today you'll be ready to do 1.2 homework. Now, up until your algebra days, you were asked to graph on a number line. And of course, that is a one-dimensional graph. Goes from left to right. And then in pre-algebra, you were told to graph on a Cartesian coordinate system, which is a two-dimensional graph. And that is your y-axis and your x-axis. And of course, you were told to do points in x and y, and go x perform units and y units, and that's your point. And you were told to write that in x comma y terms. Okay, all that's pre-algebra. And then in algebra 1, you were told that your slope is equal to delta y over delta x, which is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you were told that once you find your slope, you can plug it in your point slope equation, which is y minus y sub 1 is equal to m times x minus x sub 1. You need to remember that, so you need to highlight that, because that's test questions on your Unit 1 test in the review section. So to see how much you can remember, 3 ways that you are given a question on these two. You may be given a line with no points, just a piece of graph paper, and given a line and you pick 2 points. You may be given a line, and they have 2 points picked. And you use the 2 points. Or, they may give you C, which they give you 2 points. 2 comma 2, 5 comma 5. I want you to do this one. I want you to find the slope, and I want you to plug it into the equation and tell me what the equation of that line is going through those 2 points. Now, there's 3 type people in here. One's going, oh yeah, I know how to do that. And the other one's going, I remember a little bit, but I don't remember all of it. And then there's one saying, I have no idea what he's talking about. Right? Well, I'm going to teach to the one that says, I don't have any idea what he's talking about. So after you've tried, or after you sit there and meditate for about 15 minutes, and you don't know what you're doing, I'll go over it, and then everybody should be up to snuff on how to do it. So go ahead and try it, and if you can't, just meditate on. Mr. Kraft, were you able to get on?
Yeah.
Good. What was exactly the problem?
She said, I registered at a weird time, so I didn't know.
It didn't dump into the, okay.
She also got on.
She gets on to everybody. I don't know why people change their password, because if they leave it as a T number, they won't have any trouble. But for some reason,
I just remember that.
Okay. Find the slope, and then after you find the slope, plug and chug. I get these jelly beans at Tractor Supply, and I've addicted to them. I don't even like regular jelly beans, I just like the sour ones. And I buy like 5 or 6 bags at a time. Got this big old bowl in my den on the coffee table, and it's full of these daggum jelly beans. They're called sour gourmet jelly beans. They're like $2 a bag at Tractor Supply. Well, when you go in the door to the right, there's a basket of stuff over here, right in front of the BB guns. It's on the other side. And it's usually empty because I buy all of them. It usually holds about 10 bags, and I buy about 6 of them. I love them. My mama steals them. She'll come in and grab a handful and put in her pocket. When she's sober.
We bought hay for something, that works for my husband.
I bought hay.
I did.
Johnny Shangley?
John, yeah.
Yeah, that's my cousin. Over there on 187?
Kevin got it.
Yeah, I'm about down to 10 bales, but I got about 40 or 50 old bales that I'm using.
It was a round bale.
All right. Which way do we read? Left to right. So this is, left to right. So this is y sub 1, x of 1, y sub 1. This is x sub 2, y sub 2. Find the slope. Parenthesis minus parenthesis over parenthesis minus parenthesis. 5 minus 2 over 5 minus 2. And that's equal to 3 over 3, which is equal to what? So our slope of that line is equal to 1. So now you pick a point. I'm going to pick 2 and 2. You can pick 5 and 5 if you want to, and m is equal to 1. This is part 1. Part 2, you pick a point, then you find the slope and you plug into the slope equation. Y minus parentheses is equal to parentheses times x minus parentheses. Two, 1, 2. Y minus 2 is equal to x minus 2. Bring the 2 over. Y is equal to x. And that's how you find your equation of a line. Now, hopefully, most of you are saying to yourself, okay, I remember that. That's good. Okay. Now, you should be going to your review homework or the 1.2 homework, and you should be doing some more of this. Now, I don't do this fast with a section, all right? 1.2 is still review, okay? So when I get to chapter 2, that's when I'm going to start slowing down a little bit as far as what you should know and what you don't know and that kind of thing. So most of you, how many of you remember this? Raise your hands. So everybody's raising their hands. So everybody should be good on this. Now let's talk about the 3 methods of graphing. Just as a review, method 1 is called the chart plot method. Method 2 is called the intercept method. Now this is how to graph a line. This is not finding the equation of a line. This is the different methods of graphing. Method 3 is called the building a line method. Again, as I go over these, you're going to say, oh yeah, I remember how to do that. Y is equal to 2x plus 6. Draw a chart. -2, -1, 0, 1, 2. -2 times 2 is what? -4 plus 6 is 2. -1, -2 plus 6 is 4. 0 plus 6 is 6. 1 times 2 is 2 plus 6 is 8. And 2 times 2 is 4 plus 6 is 10. And then you plot your point. -2, +2. -1, +4. 0, 6. 1, 8. And 2, 10. Now, the reason everybody should know that one is because that's the first one we learned back in pre-algebra. So everybody should be saying, oh yeah, I know how to do that. Intercept method. 2x plus 4y is equal to 8. What do you notice different about the way this one is written and the way this one is written? Why isn't it by itself? So you need to take your handy dandy highlighter. And you need to highlight this guy, because when y is by itself, you're going to use method 1 or method 3. When y is not by itself, you're going to use method 2. Now, notice I didn't say when y is not by itself, you solve for y and do method 1 or 3. I didn't say that. Just like you don't use a screwdriver for a nail. Okay? One of the things in mathematics, this is the hardest thing to get across to NASA engineers, is that there are different tools for different things. You don't use a screwdriver to drive a nail. Okay? You don't use a socket wrench or a ratchet, it's not socket, whatever we call it, to drive a screw. Okay? You don't use method 1 to do that problem right there. NASA engineers, they go with, oh well, I just solved y and use method 1. Well, when you're asked to find the intercepts, you won't be able to do it. There's a reason for everything, and there's a reason for method 2. Whenever you want to find the x-intercept, you plug in 0 for y. So what I tell students to do is just draw a big chart. And here I'm going to put x-intercept, plug in 0 for y, y-intercept, plug in 0 for x. And then here, I put my formula, I'm going to put my equation right here. Did you notice where I put the equation in relation to the x and the y-intercept? I put it to where when you plug in 0 for y, you just drop down an arrow right there. And x, you just drop down an arrow right there. So 2x plus 4 times 0 is equal to 8. 2x is equal to 8. X is equal to 4, and that 4 2 times 0 plus 4y is equal to 8. So y is equal to 8, y is equal to 2. Then plot those 2 points. 4 and 0. 2 and 0. Hopefully all of you are going, oh yeah, I remember seeing that. Remember? Yes, ma'am. A lot of people cover the term with this going. You can do that if you want to. And then the third is building a line. Y is equal to 2x minus 3. Extract A. What is your y-intercept? 0, negative 3. B. What is the direction of the slope? It's positive. Therefore, it's left to right up. And C. Your slope is 2 over 1, which means your vertical over your horizontal. And how did I find that? Well, take your highlighter out. I'm going to highlight this number. And that is this right here. This right here, which is the sine of the 2, gives you that. and the 2 gives you 2 over 1. So you don't have to do any math, and now you plot the points. 0, -3. You got a positive slope, which means left to right up, and then 1, 2, 1. 1, 2, 1. 1, 2, 1. And after you do 5 or 6 points, draw your line. And those are the 3 methods of graphing. How are we doing so far? Everybody remember? Cobwebs? Cobwebs loosening up a little bit? Good. Now, what about domain and range? Well, domain and range is usually brought upon right before a nonlinear section. Back a long time ago, before the hotels that they have now, there was one of these on every floor. Somebody know what it is? Ice machine. Good. Ice machine runs off of water. And the output is ice. Now, let's talk about this for a minute. What if I was to take a funnel, and I know y'all don't know what funnel is, because y'all don't drink or anything. Take a funnel, and we put a funnel instead of a water line. We hook the funnel up to that line, and we pour in 5 gallons of cherry Kool-Aid. Okay? Poured in that funnel. What would happen? We'd get 5 gallons of what? Or we'd get a bucket full of what? Cherry ice. Would we not? Okay, if I put in 10 gallons of grape Kool-Aid, I'd get 10 gallons of grape ice. So is it fair to say that the range, which is the output, depends on the what? Depends on the input, right? The output depends on the input. The input is called the what? Domain. So think of the ice machine is the function, and the input is the water, and the output is the ice. Same thing with a bicycle. I got in trouble about this. You don't believe it. Offended. Somebody got offended. Okay, there's a suit and there's bicycle. Notice I still use it because I think they're retarded for whatever they said. Okay? In order for you to ride a bicycle, what do you have to have? Legs. I got in trouble for saying that. Because somebody said they were offended because they have a cousin's aunt, uncle, sister's brother who got their legs knocked off over in so-and-so, so-and-so. I'm sorry, but if you put him on a bicycle, his butt's going to fall off. I'm sorry. I don't understand. I mean, I've got an uncle that lost a leg, but he ain't coming up here complaining. Okay, a bicycle is made to where you have to pedal it with your legs. And if you don't have legs, you fall down. Or if you tie your legs up, let's say that. Let's say you tie your legs up and you sit on the seat, side saddle. What's going to happen? You're going to fall down. If you have a bicycle that's run off of your hands or your arms, and you tie your arms, what are you going to do? You're just going to sit there. All right? In order for you to ride a bicycle, you have to have input. And instead of legs, we're going to say power. Okay? And power turns these what? These pedals, which turns this gear, which turns this chain, which turns this gear, which turns this what? Remember that from Calc 2, Mr. Norvell? All right? And then you get movement. Well, let's say you're running from Michael Myers in a car movie. Are you going to go slow? Your leg power, is it going to go slower? No, it's going to what? It's going to increase. And if your leg power increases, your movement what? So the output depends on the what? The input. So if I have a function, y is equal to x plus 2, my input is going to be the x. My output is going to be the y. If I tell you that x is between -2 and 2, what does that mean? That means that I can only put in -2, -1, 0, 1, and 2. So therefore, if the domain is affected, I don't know if it's A or B. If the domain is affected, what will the range be? It will be affected also. Why? Because the range always depends on what? Domain. If I constrict or if I restrict the domain, I'm also restricting the range. Leg power. If I cut the leg power, if I decrease the leg power, then what do I do to the movement of the bicycle? I decrease it. If I take out 2 gallons of cherry Kool-Aid, then I don't get 5 gallons of ice, I get 3 gallons of ice. So the domain is the independent, and which one's the dependent? Because you can't have ice if you don't have what? Water. You would be surprised on how long I went through algebra and I had no idea what they were talking about with dependent and independent variables. Has anybody ever had an algebra teacher that tried to teach you independent and dependent variable and you had no freaking idea what they were talking about? Now you do. You can't have eyes if your legs are coming. No, I'm sorry. You can't have. Oh, I'm going to hear about that one. Did I ever tell you about the bonus question? I put bonus question on y'all's test. And one of the questions says, what day is your homework due? Or when is your homework due or something? And I put Judgment Day, and I put September the 11th, 2001 or 2000, whenever it was. Okay? In December. And I get a lady that comes up, and she says, I'm offended. I rolled my eyes. I said, what? What are you offended about? And she said, oh, no, really, I'm offended because my brother's cousin's aunt's brother's sister, little boy's aunt, died in 2011. Or died 2000. When was 9/11? Was it 2011 or 2001? Okay, I can't ever keep it straight. I'm terrible with dates. It's the Russians' fault. They put stuff in my Kool-Aid. And she said, it just brings back memories. And I'm like, what about December 7th? And she goes, what's that? I might have told y'all that, but that just sits in my mind every time somebody says that to me. Didn't even know what December 7th was. What was December 7th, 1941? Thank you. Anyway, this is domain and range. Now, if you apply this to a linear function, non-linear function, it's easier to see. This is chapter 2, which I'm not going into yet. Let's just make this a dot. And let's say this is -3. And this is positive 3. What is the domain of this function? What is the x values of this function? Huh? I heard enunciate and volume. -3 to +3. That's how you say it. Not every single class I got, this is the way y'all answer questions. It's better than the voicemails I get. Y'all ever hear voicemails that you get? Y'all think I'm kidding. I had a voicemail one time that I actually took downstairs. I sent it downstairs on the phone, and I said, can y'all decipher this and let me know what they're saying? And not one single person downstairs could tell me what they were saying. And it was like, I'm exaggerating a little bit, but I couldn't understand the numbers. Y'all sound, okay, this is awful. I'm going to bring up Fat Albert. You remember Fat Albert? The cartoon that used to come on? Mushmouth. Mushmouth. Blue, 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 blue. That's what some of y'all sound like on voicemail. But I think one of y'all set it up here. -3 to +3. That's your domain. Why? Because these guys stop. Okay? And -3 to +3. So that means that if the domain is affected, what can you tell me about the range? It's affected also. Range, and we'll say that this is 9. Okay? So the range goes from 0 to what? 9. So x cannot equal 5. Nope, not in this universe. And think of it as a universe. Some of you may be Star Trek people. There was an episode of Star Trek, The Next Generation, where the little guy, that can't remember his name now, but he was a kid and he became an ensign. And he was Dr. Crusher's son. I think his name was Wesley. And he built a warp bubble. And the warp bubble was around the Enterprise. And it kept getting smaller and kept getting smaller. And guess what happened if you were near the warp bubble and it closed in on you? You vanished. Okay? Basically, think of it as your own little universe. This universe goes from -3 to +3. Does 5 exist in this universe? No. Doesn't exist in the domain. The domain is the bubble. 5,000 does not exist. The only numbers that exist in this universe is -3 to +3. Therefore, the only numbers that exist on the y-axis is 0 to what? 9. And that is what domain and range is. It's easier to see the domain and range on a graph than it is algebraic. Okay? And that's what the nonlinear function. Yes, sir.
On the range,
Mm-hmm.
shouldn't the 0 be a bracket?
No, it does. It goes through 0, 0. I'm sorry. Yeah, it should. Sorry. I meant to put a bracket. Yeah. Thank you. And that gives us what we call interval notation. And this is still a review because we haven't got chapter 2 yet. Interval notation and set builder notation. Okay? All of this comes from your inequalities. If you have these two guys, then you have an open circle, parentheses, or a dashed line. If you have these two guys, meaning that you can actually touch the number or use the number because of this, equal to, then that means you have a closed circle or a bracket or a solid line, like if you're doing feasibility regions with inequalities on the graphs. Okay, so you need to write that down. So, if my interval notation is brackets, that means I can touch 0 and use 0, and I can touch 9 and use 9 in my equation. That's interval notation, just using brackets or parentheses. Here's another example. 2 to 5. Can I use 2 in the function? No. Can I use 5 in the function? No, because it has parentheses. Because it has to do this. Set builder notation. Basically, set builder notation is this. Draw this, x such that, and then draw another brace, and then put your answer in the. This is always set builder notation, and then put your answer right here. X is greater than or equal to 4. Or x such that x is between 2 and 6. That's set builder notation. Of course, you should have went through this in 102. Hopefully, it's knocking some cobwebs loose. With a linear, let's see if you can tell me what the domain and range is with this function. Okay, tell me what the domain, write it down. Tell me what the domain and range of that function is. Who had 102 last semester? Okay? Do you remember going over some of this? Okay, how about you? How about you? Okay. How many of you had 102 like 3 semesters ago? Okay, is it coming back? Okay, good. So what would be the domain of this function? -2 for what? 5 with brackets because it's a closed circle. And then what's the range? -3 to +4. Okay, I do this with all my classes too. What is a question that you had in 102 that you never could understand? Spit it out there, because I know there's something. You know what mine was in Algebra 1 and 2? The distributive law. I could not understand why negative would change everything. And I never had anybody explain to me that negative goes with every single thing in the parentheses. And you know, for Algebra 1 and Algebra 2, or not Algebra 1, when I was here at Tech and I had to take Algebra Essentials 1 and Algebra Essentials 2, which basically mean 101 and 102. I didn't figure that out until somebody showed me, Miss Pepper, she showed me in Math 110, college algebra. Why? Can you imagine how difficult it would be to pass 101 and 102, not understanding distributing a negative changes things? Have you ever had one of those things in algebra? Spit it out there. Anything?
I couldn't get the
Set builder notation.
I could not get them.
Okay. Set builder notation revolves around this. If you have to put this on an index card, do it, because that's what gives you that. Okay. A lot of people say, I just don't understand why you put parentheses, why you put blah blah blah. And I'll say, okay, here's a piece of paper. Tell me the rule, the interval rules come off of, and they'll sit there and go, oh no. They never memorized that cloud. Yes, ma'am. Mm-hmm. So you don't understand the interval notation? Set builder notation is just a different way of writing. If I do a problem like this, hold on. If I do a problem 3x minus 2 is greater than or equal to 6. You solve it the same way you do any problem. Add 2, 3x is greater than or equal to 8. Let's make that 7. Okay, make that 9. Okay, divide by 3. Divide by 3. X is greater than or equal to what? 3. Now there's two ways I can write this answer. This is just redneck way of writing an answer. In other words, it's not sophisticated. It's just all my numbers are going to be greater than 3. And then you hold the pinky up and you write it in either interval notation. If I can, really rush it. Hold on. I'm working right now. Don't mess me up. I'm a guy, okay? I can't do two things at one time. All right, now if you remember the previous thing I told you to memorize, right here, what are we dealing with? We're dealing with these two guys. So you're dealing on a graph, you're dealing with a closed circle, and on interval notation, you're dealing with this. Okay? Set builder notation really doesn't have anything to do with this. So I say, okay, these numbers are greater than or equal to 3, so I put a closed circle here. And I take my handy dandy virtual highlighter and I highlight all of these numbers. And of course, from grade school, you know this arrowhead is called negative infinity, and this arrowhead is called what? Positive infinity. So my interval notation says, okay, 3, and that's a closed circle, so it gets a bracket. And then infinity always gets a parenthesis. That's interval notation. Set builder notation is real simple. You just do this. And you put your RedNet answer in here. That's it.
You know how complicated that is?
Yes, because I sucked at algebra and I had to take algebra 1 and 2 5 or 6 times because of the teacher. So I know. I had Joe Stearns.
I'm talking about 3 weeks.
Yeah, that's all there is to it. Joe Stearns. Have you ever had Joe Stearns? No. He's a nice guy. He just can't tell you how to get out of the wet paper sack. I mean, he's terrible. Good guy, good heart, but he can't tell you how to do anything on math. How about another question that always irritated you? Does that help when you set builder and interval notation?
Yes.
How about another question that always irritated you about algebra? Anybody? Y'all just all know it all. Okay, good. Y'all just very smart. Is that it? I can't believe nothing ever irritated. Yes, sir. Factoring. Which factoring? Tell me what kind of factoring. The reverse FOIL method? Oh, you know it now. But it always gave, and do you realize how simple that is? It's very simple, but it's all how it's presented. Honestly, you can have 2 or 3 teachers lined up, and 2 of them can teach it, and it'll be easy. The last one can totally lobotomize you on what you just understood from the first two. It all depends on the presentation. All right, anybody else, before we move on, anything else y'all want to get out as a question or something you never understood?
I couldn't get the functions, but now I realize doing this, it's just replacing. It's plugging in the number.
That's it. The function is the actual ice machine. F of x is equal to x squared plus 2x plus 4. X squared plus 2x plus 4 is the ice machine. Your x is the water, your y is the ice. You had another one. What was yours? Huh? Not this one, because graphing, remember I told you the other day, I might have, or it might have been in my calculus class. In algebra, there's 2 objectives, 2 or 3 objectives. One is to find x. Okay? 2 is to graph. And 3, I might have had it in a different order, is to factor. Okay? Those are 3 objectives. Each one has kind of a different way of writing, or way it's written. This one is going to be written like this. 2x minus 3y. Oops, I'm sorry. 2x. I came in here this morning, and this was an eraser. By the end of the day, it's green. Now, you explain that to me. I haven't had training, so I have no idea. I know it has something to do with this button and, I don't know. 2x minus 3 is equal to 4. All right, you see how that's written? Okay, that is a solving for x type problem. This one is going to be y is equal to 4x minus 3, or it's going to be 2x plus 4y is equal to 12. See the difference? Okay. This one, usually, unless it's asking for the x-intercept, it's not going to have a what? It's not going to have x. Oops, sorry. There. Most of the time, it's not going to have x. So, in this case, if you said factor, you just dumb, I did exactly what I did want to do. I factored it while I was doing it. Sorry. Let me just erase it. Let me do that one over. I get kind of cart before the horse. There we go. There's no equal sign. This is an expression. An expression does not have an equal sign. And usually this is going to say factor or rewrite or simplify. It's not going to say solve. This is going to say graph. This is going to say solve. This is going to say simplify or what? Factor or rewrite. So just remember that whenever you're looking at an algebraic sentence. And it's kind of like when you see, where is the dog? There's no, what do you call it, thing at the end? What do you call that in English when you put something at the end of the sentence? Punctuation. There's no punctuation mark or whatever, punctuation, but you know it's a what? Why? Thank you, English person. Because of the thing, the word that says where, what is that called? Where, what is that called? Is that a preposition or something? I have no idea. Okay? Now you see how dumb I am. Okay? That where does everything. Now in math, the equal sign or the word that tells you the directions tells you the context of the question. Okay? Who's got another one?
There was one I couldn't figure out. There's another function that I still don't get.
What does it say?
It says find f, and then it has parentheses -2, when f of x is equal to 2 minus 3x. Well,
Okay.
But it says express your answer in the order pair.
Okay.
That's what I don't
Ordered pairs according. All right, let me show you something. That's leading on to the next part of the review. Next part of the review / going into chapter 2 is kind of in the middle. Okay? In pre-algebra, up to algebra 1, you were redneck pretty much. In other words, the best way to get the answer, when you write the answer, and that's it. You get to algebra 2, in college algebra, you can't be a redneck. You got to hold your pinky up when you talk or when you drink, because you got to be sophisticated. All right. Back in algebra 1 in pre-algebra, you were told take x plus 4 and add x minus 6. And you sat there and you went, okay, distribute this 1. That's positive 1, so I get x plus 4 plus x minus 6. 1x plus 1x is 2x, and 4 minus 6 is -2. And in pre-algebra, you were told take 2x plus 4 and subtract x minus 2. And you had a 1 here, and you distributed that 1, and you got a -1 here, and you distributed that -1, and you got 2x plus 4 minus 1x plus what? 2. 2x minus 1x is 1x, or x. And 4 plus 2 is 6. So in this case, here you added, and what did you do here? You subtracted 2 terms, right? Well, can't do it that way anymore, because you sophisticated now. So what you do is you go f of x is equal to x plus 4, g of x, notice my pinky is up, is equal to x minus 6, and I want to add f plus g of x. And guess what? It's the same thing that you got back when you were ready. 2x minus 2. F minus g of x is what? X plus 6. Okay, let's talk about multiplying. Well, back in pre-algebra, when you didn't know what you were doing, but you knew what you were doing, sometimes we do things and we have no idea what we're doing until later. Well, that's the way pre-algebra and algebra 1 is. And here we multiply full way, and we do x minus 2 times x plus 6. And we use our old friend of what? The FOIL method. Pronounce it however you like. X squared plus 6x minus 2x minus 12. These two combined, x squared plus 3x, or 4x, minus 12. Can't do it that way anymore, because that's not sophisticated. Now you have to do this. You'd be surprised at how many students can do pre-algebra and algebra 1. They get to algebra 2 or 102, and they're told to do everything as a function and have no idea what to do. And they did it back in pre-algebra and algebra 1. Same thing. And this is what your question says. Your question says the following. Back in pre-algebra and algebra 1, it said this. Anybody want to come up here and learn how to use this thing? I wish you would. 3 years. Going on 3 years we've had it. Haven't had a single bit of training on it. X squared plus 4x plus 4. X is equal to 2. When have you seen that in algebra 1? What'd you do? Huh? Plugged and what? Plugged and chugged. Now y'all know why I got a big cup up here. Don't ask what's in it. I have to kid about that because I could think about it being alcohol and somebody would fill my department here. So a psychology teacher can come in and get sauce in front of y'all and nobody say a word to me. And what I do, put a 2 here and 2 here. And x is what? When x is equal to 2, what am I going to get? If I plug in 2, what am I going to get? You plug in x, you get y. Right? So 2 squared is what? 4 plus 8 plus 4. What's 8 plus 8? Now, can't do it that way because you need to be sophisticated. F of x is equal to x squared plus 4x plus 4. Please find f of 2. And f of 2 is 16. You've been doing it for the last 2 semesters. Nothing different. If I give you does that make better sense? An ordered pair is 25-cent word for coordinate, x and y. How about something else? One more. Anybody? All right, I'm going to let y'all go. That gives y'all 1.2, and it gives y'all a little bit of going into chapter 2. Because if you'll know the truth about it, what I just covered is like 3 sections in chapter 2. Okay? So you got enough to work on for a couple of. Mr. Weaver, I'm shutting her off, okay? He's probably 3 or 4 miles down the road at a